Okay, welcome to another Happy Monday. Today we are going to be reviewing the two subjects we talked about right before we were dismissed. Probability and interior and exterior angles of polygons. So first we'll start with the probability. And we're looking at a two-way table right here. And the problem is, an airline wants to determine if passengers not checking luggage is related to people being on business trips. So it's like they have a quick trip and they're just going to carry on their baggage. Data for 1,000 random passengers at an airport was collected and summarized in the table below. So here we have two rows. We have traveling for business or not traveling for business. And then we have they checked baggage or they did not check baggage. Okay, so what if we wanted to find the total number of people that checked baggage? We would just add 103 plus 216. And that gives us 319 people checked baggage. What about the total number of people traveling for business? That would be 103 plus 387. So that would be 490 people. What about the people not traveling for business? 216 plus 294, and that gives us 510. And then the people that did not check baggage, 387 plus 294. It's going to give us 681 people did not. Now, what do we notice about 490 plus 510 and 319 plus 681 is that they both add up to 1,000, which are the total number of passengers that they asked. Okay, so now that we've got the margins filled out in the two-way table, we should be able to answer these questions. What is the probability that a passenger did not check baggage? So said nothing if they were traveling on business or not. Just did they check baggage? Well, 319 out of 1,000 people check baggage, and 681 out of 1,000 people did not. Remember, it was did not check baggage. So the probability would be 681 divided by 1,000, which as a decimal is 0.681 or 68.1%. Okay, now if a passenger is traveling for business, what is the probability that the passenger did not check baggage? Okay, so this is a conditional probability, and we're looking for the probability that the passenger did not check baggage given that this passenger was traveling on business. So for business. Okay. So from a two-way table, we don't have to use the multiplication rule. We can just check from the table. We're only looking out of the passengers that traveled for business. So that would be 490. So we know that the denominator is going to be 490. We're only looking in that group. And then out of those 490 people, how many did not check baggage? 387. So 387 out of those 490 people that were traveling for business did not check baggage. Okay, as a decimal, we would just divide 387 by 490 and get about 79%. So about 0.79, which is about 79%. So a clear majority of these people that weren't checking baggage were traveling for business. Okay? So that speaks to that association that yes, if you are traveling for business, you're going to be more likely not to check baggage. Okay, so now we're going to switch gears, and this was the last thing that we studied in the beginning of chapter 8, which were the interior and exterior angles of polygons. So first, let's come up with the formula for finding the sum of interior angles of a polygon. Okay, so this is for any polygon, and we derive this where n is the number of sides of the polygon, and then the formula that we use to get the sum of interior angles is n minus 2 times 180. Okay, so remember it started out with the triangle. Triangle has 3 sides, and we know that the sum of their interior angles is 180. When we have a quadrilateral with 4 sides, we know that the sum of the interior angles is going to be 360. Okay, think of a square or rectangle with 4 90-degree angles. And then we extended it to pentagons, hexagons, and so on. So we found that this formula would always tell us the sum of the interior angles. Okay, so let's look at example 1. This is the sum of the interior angles of a heptagon. Not a shape that we typically talk about with 7 sides. So this is not a regular heptagon. Okay, so maybe looks something like this. Okay, 1, 2, 3, 4, 5, 6, 7. That's 7 sides. So we want to find the sum of these angles. Okay, and we would use the formula. And since it has 7 sides, n is going to be equal to 7. So it's going to be 7 minus 2 in the parentheses times 180. That gives us 5 times 180, and that gives us 900. That's it. Okay. Now something you would not be able to do with this particular heptagon, because the sides are not the same, is finding the measure of each interior angle. Okay. These interior angles are going to be different. Okay. So with a regular polygon, all the interior angles are going to be the same, as well as all the sides. And so you would use the same formula, n minus 2 times 180, but then you would divide by the number of sides, n. Okay, and it's very important. This is for regular polygons only. Okay, so let's try one of those problems. And so for example 2, it's find the measure of the interior angle of a regular octagon with 8 sides. So that's a stop sign, right? So we have 1, 2, 3, 5, 6. Okay, and all these sides, all 8 of them are the same length. Okay, so we want to find each of these angles, because if we find one, we're going to find the measure of them all because they're all the same measure. Okay, so we know that n, the number of sides, is 8, and so we would plug it into the formula. 8 minus 2 times 180 divided by 8. And so that gives us 6 times 180 divided by 8. And 6 times 180 is 1080 divided by 8. And 1080 divided by 8 is 135. Okay, so each one of these angles here is 135 degrees. Okay. Now the next type of angle that we looked at was an exterior angle. Okay, and an exterior angle, let's say I have a triangle here. Okay, these are the interior angles. The exterior angle, we have to extend the side, and this right here would be the exterior angle. Okay, and so this would have, this triangle would have 3 exterior angles, right here, right here, and right here. Okay, so there's the same number of exterior angles as interior angles. And the sum of exterior angles for all polygons, not just regular ones, is 360 degrees. Okay, so like interior angles with regular polygons, they are also equal. They're all the same. And so to get, for regular polygon, the measure of 1, we would just take 360 and divide by the number of sides. So 360 divided by n. So in example 3 says, find the measure of the exterior angle of a regular decagon with 10 sides. Well, see, this is very simple here. We just take 360, because the sum of all the exterior angles will be 360, and divide by 10. And so the exterior angle is going to be 36 degrees. That's it. Okay. Now, taking it a step further, what if we want to find the number of sides in a regular polygon? Okay. So let's say we want to solve for n. So let's say we know what the interior angle is, but we're trying to solve for n. Okay. Or if they give us the exterior angle, we would use this, 360 divided by n. Okay, so in example 4, it says find the number of sides for a regular polygon if each interior angle is 150 degrees. So they tell us the interior angle, so we're going to use this formula. And so n minus 2 times 180 divided by n would give us 150. Okay. And guess what here? We need to use algebra to solve. Okay. So here, since we've got a ratio here, we've got a whole number here, I'm just going to write that over 1 and cross multiply. And so that would just give us 1 times n minus 2 times 180 on that side equals 150 times n. So 150n on this side. And then I would distribute the 180 on the left-hand side, giving me 180n minus 360 equals 150n. And then I'm going to subtract 150n from both sides. So that's going to give me 30n minus 360 equals 0. Add 360 to both sides. (30n) equals 360, and then divide by 30. And so n is equal to 12. And so this regular polygon has 12 sides. I believe that's a dodecagon. And that's how you would solve for the number of sides. Now, if they gave me each exterior angle is 30 degrees, then I would use this formula and set 360 over n equal to 30, cross multiply, and solve for n. All right, so that's it for today. Look for your assignment coming tonight along with this video and the notes. And no meetings this week. There's AP testing going on, so I don't want to disturb that. So we'll just keep in touch with me this week and hope to hear from you guys. All right, have a good one.